25 points on the written part of the test. I just let it ride. So some of you have some inflated scores. It's okay. You're lucky. My bad, you're lucky. Okay. So the multiple choice questions are on the board. And we'll entertain questions about the multiple choice if you would like.
Wow.
Yes? The paper was kind of crinkly. It may be the problem. Let me see it after class. I'll take a look at it. Yes, ma'am?
It says, so which is following the composition?
Oh, sure. Salt water. Put more salt in, put more water in. Mixtures, any kind of mixture, the composition can vary. The email was sent out indicating that because half the exams were missing the extra credit, you can turn them all in on Friday. And I sent the extra credit to you by email. So if you haven't seen that email, you still have a chance to do the extra credit. You can turn it in Friday. If you want to turn it in today, you're welcome to. I'll be glad to take it. It's up to you. Yes, sir.
Number 10 says the charge oxidation number on the manganese and the salt, potassium manganese is seven.
What was the formula KMNO4?
Yes.
What's your name?
I get this wrong. Why is that this? I don't think it's not.
So here's the formula. The charge on the potassium, since it's a group 1 metal, should be +1. You're looking for the number on the manganese, and the charge on the oxygen should be -2 in a compound, and there's 4 of them, and the total must be 0. So I think what you get here is that the number on the MN must equal a +7. Any others? Which color? Green, 20. It's number 2 on the pink or purple test. And yeah, you know that density is equal to mass over volume, and so it's asking you for the volume. Okay, and you're given the mass and the density, so I took 9.83 grams and divided by 13.6 grams per cubic centimeter and came up with 0.723 cubic centimeters. Any others on the multiple choice?
For number 19, it says if matter is uniform throughout, cannot be separated into other substances by physical processes, but can be decomposed. It can be homogeneous mixture because you can't separate pure substance.
Homogeneous mixtures can be separated by physical means. Salt and water, you can boil it, so it has to be compound. What answer did you put?
I put homogeneous, but the answer is compound.
The answer is compound, because a homogeneous mixture can be separated by physical means. If I have salt and water, I can boil the water, re-level it with salt.
Did you do this one already? Let's see. Number 21 on purple.
21 on the purple is number 17 on the green.
I just don't know how to do those.
I took 45 meters per second multiplied by 1 kilometer over 1,000 meters multiplied by 60 seconds over 1 minute multiplied by 60 minutes over 1 hour. Came up with 162 kilometers per hour.
Okay.
Any others?
Number
Yes, ma'am.
19 purple. Oh, I'm sorry.
No, number 19.
Number 19, purple. Sure. I have 8.4 pennyweights. There are 24 grains for 1 pennyweight. There's 100 or 1 ounce, sorry, per 480 grains, and $265 per 1 ounce. So I ended up with $111.30 for the whole chain.
I do everything, and then I was like, I don't know the answer to this, so both of these things are
So you did everything right and then decided to put the wrong answer. Okay.
Like, I got all the words for it, like, everything is set out exactly the right way. I don't know, just that.
Anything else?
Number 2, green.
Number 2 on the green. It's number 9 on the purple. And I got answer A. I'll go through and tell you why the other answers are not good. B, Na2 is not a recognized form of sodium. It has to be just a metal. In C, you have an unbalanced reaction. The nitrogens don't balance. In D, you've got a molecule of nitrogen and an atom of nitrogen, and that would not be acceptable. And in E, you have, is it unbalanced? Yeah, it's the nitrogens are wrong. So the only one that turns out with correct formulas and balancing is A.
Dr. Brown, you said for number 2, for the sodium, the Na2 is the correct formula for
Right, it's incorrect.
you said
Na2 does not exist.
How are we supposed to know that stuff? Well, I didn't see that anywhere.
It's also not balanced though.
Yeah,
There's 6 nitrogen. Indeed.
yeah, I got D.
I don't know, that's a pretty good question. I guess because metals just always occur as single elements, we never gave an indication that they would be doubled. We talked about some of the non-metals being doubled, but never any of the metals. And you've never seen that anywhere. I would question where you're coming from with that. Why you would pick D over C, over A.
Or I picked D. I was just wondering.
You picked D? Yeah, that's wrong. Any others? Yes, sir.
Number 3 on the green.
Number 3 on the green. Okay, you have to evaluate the stuff in the parentheses first, using the rules for addition and subtraction. And so I get 8.5 for the first parentheses. I get 120.0 for the second parentheses. Now it's just multiplication, and you can keep two significant figures in your answer. And so I get 4.4. Any others? Yes? $26 on the purple. Okay, that's not a multiple choice, so we'll go on. Any more multiple choice? 26 on the purple is the same as 26 on the green. And you're asked to complete this little table of values. So you're given the first information is you have a magnesium atom. It's atomic number 12, mass number 26. So the atomic number is 12, mass number is 26. Comes straight from this symbolism. Atomic number is equal to the number of protons, so that should be 12. Number of neutrons is the mass number minus the number of protons, so that's 14. Number of electrons should be 12 because it's a neutral chemical species. Now, when this is given to you in this block here, you can't change that. And a lot of people change that to an ion and then adjusted the number of electrons. This time, if you did that correctly, you gave me an ion charge and adjusted the number of electrons, I gave you credit. But in the future, don't be changing my problem. Suit your needs. You have to deal with what I give you. So in the second row, you have an atomic number of 22. Periodic table tells me that that's titanium. So I have the titanium 22. It gives me a mass number of 48, which means I can calculate that there are 26 neutrons. The mass number is what goes up in the upper left-hand corner, so it's 48. So the number of neutrons is 26. And since there's only 20 electrons, now it has to be an ion, so it's a +2 ion. So you needed to have this symbol here with all that information to be correct on that. So,
Can you go over that part again?
sure. The atomic number tells me the number of protons.
Okay.
So these have to be equal. It also identifies the element for me, so I know it's titanium. So it's titanium with 22 here.
Mm-hmm.
Then the mass number is protons plus neutrons. So if I subtract this from this, I should get the number of neutrons, and that's 26.
Mm-hmm.
This is the mass number, so it's exactly what this number is here, 48. And then since there's only 20 electrons with 22 protons, it must carry a charge of +2.
Okay.
I got a question.
Yeah.
Can we talk to you afterwards if one of the questions is marked off, but it's actually right in Scantron
Yeah, you can talk to me
afterwards?
afterwards. And I'll make sure I didn't put the wrong number up here, so. I have a tendency to do that. All right, the formulas and names I think were the same on both exams. So silver nitrate, aluminum fluoride, spelled correctly, it's FLUORIDE. Cobalt 2 bromide, you have to have the 2, it's a transition metal, indicates the charge on the cobalt. Then iron 3 sulfide would be Fe2S3, sodium dichromate Na2, Cr2O7, and calcium phosphide would be Ca3P2. So if you had those, then you should have gotten 2 points for each. If you missed something like the Roman numeral, I think I only counted as 1 point.
Did you take off for spelling? Because I spelled fluoride right, but you wrote that I spelled it wrong.
Did I take off a point? Or did I just indicate that you spelled it wrong?
I'm not sure because I got something else wrong, so I don't know how much you took off for that too.
Well, see me after class. No, I'll figure it out. Yes?
Do we not put a Roman numeral on aluminum because it's not a transition metal?
Right, you don't have to. If you did, it's okay, as long as you put the correct one, which would be a 3 in this case. If you put something incorrect, then it would be wrong. Questions? All right, next question was the empirical formula problem. These were different. on the two exams. I don't know if we can get both of them on the board or not. So in the first case, what color is that? Pink, purple? Up here, you assume 100-gram sample, and so you have the masses given by the percentages. Change them into moles, take the mole ratio, so you get an empirical formula of CHO2. The empirical formula weight would be 45, 45 to 90 is 2, and so you double everything, so I get C2H2O4. On the green, to work exactly the same way, different percentages, carbon, hydrogen, and chlorine this time instead of oxygen. Same deal, you change them to moles, take the ratio by looking, divided by the smallest. You get a 3 to 2 to 1, so C3H2Cl. That formula weight is 73.5, divided into 47, 147 is 2, so you double everything and it's C6H4Cl2. Yes, sir.
I did it completely different way.
That's okay. A lot of people took the molecular mass and converted the molecular mass, percentage of the molecular mass into moles and got the molecular formula directly. Is that what you did?
Yes, sir. Took the percentage and multiplied by the total.
Molecular mass?
Yes, sir. And then divided by the mass of the element by itself.
You got the right answer? Did you get the credit?
Yes.
There you go. There are other ways to work the problem. This is the way we did it in class. If you did it by using the molecular mass directly, that's fine. Then you would not have gotten the empirical formula, most likely. You would have just gotten the molecular formula. But that was what was asked for, so that was fine. Okay. Next question. I think it was the same on both exams. How do you get the molecular mass? Atomic mass for an element using its isotopes. You take the weight of the first isotope, which is 220.9 times its percent abundance, change to a decimal, so times 0.7422. Then you take the mass of the second isotope, 2220.0, times its fractional occurrence, and then the third isotope's mass times its fractional occurrence, and then you add those three values together. So you should have gotten about 220.4 as your final answer. Again, showing your work is the best way because some people had some rounding issues that still got them the credit because their work was there and I could see exactly what they did to get the correct answer. The extra credit, they make more money if they cut 10 heads rather than one.
Oh.
That's their preference. The extra credit rarely has anything to do with chemistry. It's a thought question, testing your critical thinking skills.
Yeah, right.
Apparently we don't have too many critical thinkers. We had a few. Okay. Any questions? Okay, so good luck to you. That did really well. Remember that if you're using this to evaluate your midterm score as to whether to drop the class or not, that there were 10 extra points on here that may have played to your favor if in fact you answered the last questions correctly. And if that was the case, then realize that your score may not be as good as you think it is when you're making that evaluation. If you have any questions about it, you can come see me and we can work out the details.
So, Dr. Byrne, the 10 points that you're referring to came from questions 28 and 29 or multiple choice?
Well, 26, 27, 28, and 29 total up to be 35 rather than 25.
Okay.
So where did they come from? Well, anybody can guess.
Okay.
I know I got
The extra credit that's gonna be due Friday, I haven't decided. I usually decide having people turn it in and then see what kind of response we get.
You mean for the points?
By the way, let me tell you about the extra credit. Apparently, I think it was the purple test did not have the extra credit attached to it. So I sent you an email that gave you the extra credit and gave you an extra 2 days. So it's due Friday. If you want to turn it in today, you're welcome to. A couple people have. If you want to keep it until Friday and turn it in the beginning of class on Friday, that's fine too. All right. Any other questions? Then we move on. Pearson.
How many points is the extra credit gonna be?
I don't know. Haven't decided yet. I'll decide once I see how many people turn it in and how they're doing it. So maybe 5, maybe 4, maybe 10. Just depends. 20, 30. I don't think it would go to 20 or 30.
Do you know what the grade distribution was?
I know what?
The score distribution was?
I can tell the average. The average was 73.5. But that's out of 110. If we norm that down straight by dividing by 110, I think it was like 68 point something, which is pretty normal for a good class to have. So 73.5 is exceptional, but when you're given an extra 10 points to play with, kind of deflates that exceptional word down a little bit. So, but I'm still proud. Okay, other questions? All right. Then we were talking about percent yield, and we said that percent yield was actual yield over theoretical yield times 100. So let's take a problem and put all this together into one stoichiometry type of problem, which will be fair game on the next exam, since we didn't have it on this. So here's a typical question. You have 1.20 grams of antimony. The problem gives you the atomic mass. You can get that from the periodic table, but by giving it to you in a problem on an exam, it saves you a little bit of time. If it's a molecular mass, you don't have to add the things together. 2.40 grams of iodine, and again, it gives you the molecular mass where the iodine are mixed, and there's the reaction to the right. Question A, how much SPI3 is made? Number 2, how much non-limiting reagent remains? And number C, that's odd. A2C. All right, make 2 of B. If 3.00 grams of antimony iodide are actually made, what is the percent yield? So go, you have 12 seconds. I'll give you 12 seconds for each part. Here, I'll give you the molecular mass for the antimony iodide too. So it's 502.5. Save you a little time.
I don't think they're the same. It's because IT is their company. So you want to enter to A in grams?
I don't care. But looking ahead,
Yeah.
you're going to have to change it to grams at some point. Weird. Yeah, that's the number 2. for the masses for one mole. So if you double it, you need to have two moles. But it's more convenient for you. So, limiting the limit flow of the cost of the kitchen. That means to slow the your batteries. 32. The lower number of cars. So you have to compute how many more different cars. They're not seeing on the road here. This is noise ODSD. And this is noise ODSD. Right, you can't tell. What you have to do is you have to say, okay, how much SBI3 can I make from this? How much SBI3 can I make from this? SBI2 to get the lower rate. Let's go back to the text. You calculate this, so you two calculate. It's 10 bodies. Okay, looking at the two. So, if I have 10 bodies, I'm going to run out of bodies before I run out of time. So every car is subject to a time. So if there's 2 tires, how many cars can I have there? So I got 2 more bodies left. But I can't put tires on. So I'm back. What's the limitation? So what I have to do is I have to say, how many cars can I make with these tires? How many cars can I make with these tires? With the small people.
My neighbor committed suicide last night.
Neighbor what?
Committed suicide last night.
Oh, wow.
Little off.
Were they off?
Yes.
Oh, still.
8 months.
Children?
No.
Sounds good.
This is the final damage now. I'm really
Well, what are you trying to do? You're trying to relate to, what is this? So you're trying to relate the nodes of SB to the nodes of SB. That relationship always comes from right, we need to do it?
Right.
So for part A, start out with what I'm given. I'm given 1.20 grams of antimony. And the tattoo on my arm tells me to change that to moles. So 1 mole of antimony is 121.8 grams. That comes straight from the periodic table. I've just saved you a little time by giving it to you in the problem. So you do that calculation and you get 0.00985 moles of antimony. Let's relate that right away to the moles of antimony iodide that we make by setting up a ratio of, I'm looking for moles of antimony iodide. I know moles of antimony. The relationship comes from the balanced equation, and in this case it's 2 to 2. So that tells me that I have 0.00985 moles of antimony iodide. I do a similar calculation for the iodine. I have 2.40 grams of I2. 1 mole of I2 is, again, it's given in the problem, 253.8. If I go to the periodic table, I have to remember to double that value because I2 is a molecule, and so I'm looking for the molecular mass. So this calculation tells me that I have 0.00946 moles of iodine. I'm going to do the same thing, relate it right away to the moles of antimony iodide compared to the moles of iodine. Those numbers come from the balanced chemical equation. In this case, it's a 2 to 3. So this tells me I can make 0.00630 mole of SBI3. I can't make both. I can only make the smallest amount. So this is the winner here. And therefore, I2 is the limiting reagent because it's the one that's going to run out after that much of the SBI3 is made. So if I'm looking for the non-limiting reagent, in part B, I'm going to take the moles of iodine, and what I want to know is how many moles of antimony will I actually react with those moles of iodine. And the relationship between the antimony and the iodine, stoichiometry, comes from the balanced equation. This is 2 to 3. So this tells me that I can make 0.00630 moles of the antimony. If I change that back into grams of antimony, 121.8 grams for 1 mole, tells me that I can use 0.768 grams of antimony. So how much remains? Well, if I started out with 1.20 grams and I use 0.768 grams, the remainder must be 0.43 grams of antimony. And part C, percent yield. Well, what I didn't do over here, because I really didn't have to, was determine how much antimony iodide was actually made. I did it in terms of moles. Now I need it in terms of grams. So coming back over here, I know that I have 0.00630 moles of antimony iodide, and he tells me that it's 502.5 grams per 1 mole, so that I have a total of 3.17 grams of antimony iodide that can theoretically be made. Remember that the stoichiometric calculation is a theoretical. So in part C, to get the percent yield, I take the actual value over the theoretical value, times 100, and this leaves me with 94.6% yield. Questions?
Can you give us another?
There's plenty on the website. There's a whole list of them. I would suggest you try them and bring in the ones that you're having difficulty with. Also should be several in your textbook. Take a look at those. And we will progress to chapter 4. Now, some good news. Well, for you, I think. We had some snow days. We lost a little time. So in an effort to make up some of that time, we're going to cut out a topic. The topic we're going to cut out in chapter 4 is redox reactions. We were making you jump to chapter 18 to look at how to balance those things. We're going to let that go until chemistry 1212. We'll just make that instruction to them at that time. So any of the problem sets that are dealing with redox reactions, or there'll be no questions on the exam dealing with balancing redox reactions, we won't be covering those in class. So we'll just be looking at the reactions that are listed in chapter 4 itself. Okay, we good? We don't have much time to start chapter 4 today, so why don't we stop here, give you a little extra time to work on some stoichiometry problems. On Friday, we will plunge into chapter 4 and talk about chemical reactions.